Hello everyone. In this video, we will be discussing sidecar in microservices. Let's get started. Let's read. There are complexities encountered when transition is happening from monolith to microservices architecture and also while developing new microservices. So there are two types of complexities we encounter generally in production. One is while migration from monolith to microservices architecture or while the development of new microservices. And one of the popular ways to solve these complexities is the sidecar pattern. In this video, we will discuss what a sidecar is with its examples. Let's read the definition first. The sidecars are supporting services, module or components that are deployed along with the primary application on the same physical host. The communication with sidecar should be language agnostic. What does this mean? There are two statements in the definition. One is sidecars are supporting services. So they are not the main services, they are the supporting services which are deployed along with the primary application, the main application. That means they are deployed on the same physical host. The second is that it does not matter whether the main application is written in which language and the sidecar is written in which language. The communication between a sidecar and the primary or the main application is language agnostic. Agnostic means irrespective of what languages, let's say Python or Java or C++ they are written in, they will be able to communicate seamlessly. Let's take the example. So let's say we have a main application which is written in language one, let's say Java. And we have a sidecar which is, let's say, written in C++. This is language agnostic. That means the communication between the main application and the sidecar is not dependent on the language in which the main and the sidecars are implemented. They can be done over some APIs, let's say gRPC or HTTP, which are language agnostic. They extend some contract, and based on the contract, they communicate with each other. And they are deployed on the same physical host. So this is a shared physical infra, memory and network. So this is a host, and in this host, both the applications are deployed, the main application and the sidecar. Now, what is the popular application of a sidecar? The popular application of a sidecar is to act as a proxy. So let's say our legacy application, let's say this is over 15 years old application. So this is a legacy application. It might be very large application, which is not so easy to migrate. And there are a lot of challenges as well. So this is a legacy application is trying to support HTTPS. Let's say the time at which the application was developed, HTTP was the prominent protocol. And now it has been replaced by HTTPS company wide. So to support HTTPS, instead of rewriting the entire application, which is very costly, not in terms of time and money, but also in terms of incidents or regressions, we can just write a sidecar component to handle HTTPS concerns like security, and then use existing legacy application for HTTP. So let's say our application was handling, this is our application, main application. It is handling HTTP very correctly, but it is not able to handle HTTPS, which is nothing but HTTP over SSL or TLS at a high level, right? So this is a secure, HTTP secure. It is not able to handle HTTPS traffic. Now, after we implement the sidecar pattern, we implement a sidecar. Instead of rewriting this whole application, which is, by the way, can be a very large application and costly as well, we just write a sidecar. So whenever HTTP traffic comes, it directly is encountered by the application, as was the previous route. But if some HTTPS traffic comes, it is routed to sidecar first, which handles all the security aspects and all, and then it routes the HTTP traffic to the main application. And as usual, they are basically deployed on the same host, so they share the physical infrastructure, memory, and network. So this is the same host over which we deploy the application as well as the sidecar. And this is an example of when to use a sidecar. Instead of rewriting the main application, we have written a simple component, a shared service sidecar, which is handling the HTTPS traffic. What are the other use cases? So let's take a look. Other use cases include building sidecar for common functionalities across apps like log aggregation, for monitoring purposes so that the same functionality need not be built again and again. So let's say this is Team 1 service, this is Team 2 service, and this is Team 3 service. All these services have some common functionality. Let's say they want to have some log aggregation. Each service will be emitting some logs, right? For the traceability purpose, for debugging purpose. If any production incident happens, how do we know what the root cause is? Right? So that's why each service is bound to emit some of the logs, and these logs should be aggregated. Now, these logs aggregation is a common functionality across all the three services, and that's why it can be written as a sidecar. So this is a log aggregator, and which basically pulls all the logs, or each service pushes some logs to this, which is being aggregated by the sidecar. And they share the same physical infra, memory, and network. So also notice that first application is written in C++, second one is Go, third one is in Rust, and the log aggregator sidecar is written in Python 3. But irrespective of what languages they have been written in, this communication will be seamless. That's the definition of a sidecar. So that's all. If you have any doubt or you have any suggestion, please feel free to comment and I will be taking a look. Any other topic on which you want me to make a video, please say so in the comment, and thank you so much.